Hi everyone, I am Vipin Kumar and I welcome you all to this heat transfer lecture on Fourier's law of conduction. Okay, so as we all know, this is the starting of heat transfer subject, right? And we have all in all three modes of heat transfer: conduction, convection, and radiation. Okay, and whenever we start talking about conduction, we start with the Fourier's law of conduction. So in this lecture, we are going to talk about some basic things on the conduction and then the governing law of conduction, which is Fourier's law. Okay, chalo. Before that, a brief introduction. I have around 5+ years of teaching experience. I have done my MTech from IIT Kharagpur. I have done my MSc from Politecnico di Milano. I have 3.5 years of industry as well as research experience, few research publications, and my area of expertise is thermal basic and applied and heat and mass transfer. Okay, chalo. Now, without delay, let us start the lecture for today. Now, there are three modes of heat transfer, as we all know. First is conduction, convection, and radiation. In this lecture, we are going to focus on conduction. First of all, how the mechanism of conduction in solids, liquids, and gases. How conduction happens or conduction heat transfer happens in solid, liquids, and gases. And we are going to talk about the governing law, which is Fourier's law of conduction, governing law of conduction, which is Fourier's law of conduction, right? Chalo, let us move on. Now, first of all, what is conduction? So let us read the statement first, and then we'll discuss. We will break it down, and we will discuss the physical significance of it. Okay. So it is a mode of heat transfer that occurs due to temperature difference within the same body or from one body to another that are in physical contact. Okay, chalo. Let us see. Look, you have a body, one body, and this side the temperature is T1 and this side the temperature is T2. Okay, and I am saying T1 is greater than T2. Because in the same body, it is a body, it is single body, but we have maintained the two sides of the same body at different temperatures. So there is a temperature difference. Okay, so first condition is satisfied. Then within the same body it's satisfied. Okay, and due to temperature difference and within the same body. Okay, so both conditions are satisfied, so there will be a heat transfer from this side to this side, and this is called as conduction. This is the first thing. Now let us take one more body. So let us take one more body. We have another body, and this size temperature is T3 and T3 is lower than T2. Now what will happen? Now the heat transfer will take place from one body to the another body because of temperature difference. Okay, so heat transfer will flow like this. Okay, so there are three conditions that must be satisfied. First, temperature difference must be there. Second, it may happen within the same body or from one body to another. And if it is happening from one body to another, there must be a physical contact. There must be a physical contact. So I can write here conduction is a internal phenomena. Internal, why it is an internal phenomena? It happens inside the body. It is an internal phenomena. What are the conditions? Look, एक तो temperature difference होना चाहिए. Temperature difference must be there. Temperature difference होना चाहिए. और अगर it is happening in from one body to another, then physical contact भी होना चाहिए. तो अगर these conditions are satisfied, then it is called as conduction. Okay, now it meant it can take place in solid, liquids, and gases. Okay, chalo, let us talk about how the conduction happens in solids. We are only talking about solids. Okay, chalo, let us take a solid body. This is a solid body. Okay, now there are molecules who are bound together to each other, right? Molecules that are bound together to each other. These are molecules that are bound together to each other, and there are some free electrons as well. Free electrons here, 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 here. Okay, now as soon as you provide heating, okay, for example, you have given fire here. Okay, fire here. So what will happen? This side temperature will be higher, T1, and the other side temperature will be lower. Now what will happen? The molecules that are closer to the hot side will start vibrating about its mean position. It will start vibrate. It will start vibrate. This is also going to vibrate. And when they are vibrating, it is going to collide with the other molecule and it is going to transfer heat. Similarly, this is going to vibrate. It is going to transfer heat. That is called as molecular lattice vibration energy transfer. Energy transfer that happens because of the vibration of molecules. It is called as molecular lattice vibration energy transfer. Okay. Now, what is the second phenomena? Look, there are free electrons as well. Now, because of the heating, when you are providing heating, this electron's energy state will increase. It will go to higher energy state. It is going to jump from one place to another and provide energy to the another electron. Now this is going to jump. It is going to provide energy to another electron. So this energy is getting transferred because of the free electron motion. Okay, it is called as free electron energy transfer. So in solids, conduction heat transfer takes place because of two reasons. First is molecular lattice vibration energy and free electron transfer, Okay, now in metals, for metals, what happens? Large number of free electrons are there, and therefore second B phenomena dominates. Most of the heat transfer takes place because of it dominates. Okay, in metals, okay. But when we talk about in non-metals, for non-metals, they have very low or no free electrons, and therefore what is the only phenomena that takes place here? A phenomena dominates. Okay, so if someone asks you how the heat transfer takes place in solids, conduction heat transfer takes place in solid because of these two phenomena. In metals, free electron energy transfer dominates. In non-metals, molecular lattice vibration energy phenomena dominates. Okay, chalo. Let's talk about liquids. Now in liquid, what happens? You see, let's say you have some water here. This is a bucket and there is some, we are talking about liquids. Okay, so there is some water here. Water. Okay, now we have one molecule of H2O, we have another molecule of H2O, we have other molecules of H2O. So they are far apart, but not very, very far apart. So there is an intermolecular force. There is some intermolecular force, between molecules, right? In liquids, we have some intermolecular force. Okay, now what will happen? Let's say you start a fire here. You are giving heat by applying fire. So this side will be at higher temperature T1. Okay, now this molecule, the first molecule, let's say this molecule will take some heat. Its energy state is going to increase and it is going to move and collide with another molecule. Similarly, it will take some heat. It is going to collide this one or this one, right? So first thing that is happening by absorbing heat is that molecules are moving and colliding with each other. The first phenomena is collision of molecules. Okay, now because there are intermolecular forces, what is happening? Molecules are joined together for some time. They are in contact for some time. And when they are in contact, the heat is diffused from one molecule to another molecule. Okay, for example, let's say this is the another molecule. Now heat is getting diffused. Heat is diffused from one molecule to another molecule. And it will only happen, this diffusion of heat will only happen if they are in contact for some time. And in liquid, it happens because of the intermolecular forces between molecules. If there is no intermolecular forces, they are not going to remain in contact. Okay, so in the liquids, heat transfer takes place because of two phenomena. First, collision of molecule. Second, diffusion of heat. Okay, so intermolecular forces between molecules play a major role. In conduction heat transfer in liquids. because it is the intermolecular force that is holding two molecules together, and then only the diffusion of heat is taking place. Okay, chalo. What about in gases? In gases, now the problem with gases is that if this bucket has gas, so one molecule is here, one molecule is here, one molecule is, molecules are very, very far apart from each other, and there is no intermolecular force, no intermolecular forces, no intermolecular forces between molecules, and therefore the when you provide heat, they are going to collide, yes, but they are not going to remain in contact. So no diffusion heat transfer, no diffusion heat transfer. The only heat transfer that is taking place in gases is because of collision. Very little amount of heat, it will collide, provide a little bit of energy, that's all, and that energy will be because of the velocity of the molecule. So according to kinetic theory, I can say this, where K is Boltzmann constant and this is molar mass. Okay, so can I say V square is proportional to K? Okay, or I can also say velocity is equals to under root K, and therefore it is proportional to heat transfer. So the only heat transfer that is taking place in gases is because of the motion, is because of the velocity of the molecule, that's all. Otherwise there is no diffusion of molecules, diffusion of heat, and that is the reason the only heat transfer that is happening, the only heat transfer that is taking place in gases is because of collision, and a very little of heat transfer takes place due to collision, and that is why conduction heat transfer is very, very low in gases, very, very low. Okay, so chalo. Now the other thing is the governing law for conduction, the governing law for conduction. Okay, now it is the Fourier's law of conduction. Now, before we even talk about Fourier's law, we need to understand what are the assumptions for Fourier's law of conduction. First of all, steady state heat conduction. That means temperature is not a function of time. Temperature is not changing with time. Okay, if temperature is changing with time, that means it is unsteady state, and because of that, the internal energy of the body is going to change. Okay, second is unidirectional. I am assuming that the heat transfer is taking place only in one direction, only in one direction. It could be x direction, y direction, z direction, could be one, only one, could be anything. Okay, so we are saying unidirectional heat conduction. Then no internal heat generation, there is no internal heat generation inside the body, no heat source is there inside the body. Okay, material is homogeneous and isotropic, and temperature gradient is constant. Okay, that means thermal conductivity is constant also. Okay, chalo. Now, so definition, what is the definition of Fourier's law tells you? It says that the rate of heat transfer along a given direction is directly proportional to, okay, let's say this is temperature and this is x, this is temperature and this is x. Okay, so now heat transfer in one direction, for example, if the heat transfer is in this direction, okay, now this heat transfer is proportional to the area of heat transfer. Okay, so heat transfer, whatever heat transfer is happening is proportional to area perpendicular to the direction of heat transfer, perpendicular direction of heat transfer. Okay, so if heat transfer is this is the area that we are going to talk about, perpendicular area. If this is the direction of heat transfer, this is the perpendicular area. Okay, then temperature gradient along that direction, which is q is proportional to, gradient means dt by dx, dt by dx. Okay, so this is what Fourier's law tells you. Now in order to understand that, let us take a body, let us take a plane slab. Okay, so now let us take this body. Okay, and this is the direction of x. Here x is equals to 0, here x is equals to L. Okay, and this is your direction of heat transfer. Now let us say I am assuming my temperature is T1 here and T2 here, and T1 is greater than T2. Okay, so what is the temperature gradient? How the temperature is varying with x? Like this. As x is increasing, temperature is going down. As x is increasing, temperature is going down. Okay, now what does the Fourier's law says? It says here, rate of heat transfer in a given direction, which is x, due to conduction is proportional to area perpendicular to the direction of heat transfer. What is the perpendicular area? This area. So this area is the perpendicular area. Okay, the others, both area is same, this side and that side, right? So this is the perpendicular area. What is the perpendicular area? Let's say this is width and this is height. So perpendicular area is width into height. Okay, and it is also proportional to the temperature gradient dt by dx. What is dt by dx? This is the temperature gradient dt by dx. Okay, so can I write q dot x conduction is proportional to perpendicular area dt by dx. Okay, now if I remove the proportionality sign, I can write k a dt. It is, and k here is, k is thermal conductivity. Okay, k is thermal conductivity. Okay, now you see here, look, if we talk about what is dt by dx, it is T2 minus T1 upon X2 minus X1. Now what do I know? That X2 is greater than X1, right? This is X1, this is X2. And I also know that T2 is less than T1. So because T2 is less than T1, this value will be negative. Heat transfer always takes place from high to low temperature. Okay, that is why dt by dx is negative. So this value will be negative, and heat transfer, the value of heat transfer you will get in negative. Now in order to get that positive value, we will add a minus sign here. So whenever someone asks you why the minus sign, you say to satisfy the second law of thermodynamics, which is heat transfer always takes place from high to low temperature, and because temperature gradient is negative, we will apply minus sign to make it positive. Okay, chalo. Now what is K? We need to define K, conductivity. What is conductivity? Okay, so you see Fourier's law. How do we define Fourier's law? By Q conduction is equals to minus Ka dt by dx. Okay, so for some time let us forget this minus. Okay, because it is only signifying this, that it is negative value. Okay, now if I define K from here, what is K? K is dx into Q conduction upon area dt, change in temperature. Okay, now the amount of heat transfer, for example, let us assume that thickness dx is equals to 1 meter. Change in thickness is 1 meter. I am assuming this for some time. And area is also 1 meter square, and only change in temperature is also 1 degree Celsius or 1 Kelvin. Then what will happen? K is equals to Q dot conduction. So how do you define Q dot K? How do you define conductivity? It can be defined as the rate of heat transfer, Q dot conduction, through a unit thickness. When the thickness is 1 of the material per unit area, means area is also 1, and per unit temperature difference. कितना हीट आपको देना पड़ेगा अगर आपकी थिकनेस जो है वो 1 यूनिट है, 1 मीटर है, एरिया आपका 1 मीटर स्क्वायर है, और आपका टेम्परेचर डिफरेंस भी सिर्फ 1 डिग्री सेल्सियस या 1 केल्विन है, तो जो हीट आपको देनी पड़ेगी, इट विल टेल यू कंडक्टिविटी. ओके, दैट मींस क्यू, अगर कंडक्टिविटी ज्यादा होगी तो हीट ट्रांसफर भी ज्यादा होगा. ठीक है, रेट ऑफ हीट ट्रांसफर भी ज्यादा होगा. ओके, सो इट बेसिकली टेल्स द एबिलिटी ऑफ द मटेरियल टू कंडक्ट हीट. इट इज वॉट पर मीटर केल्विन. इट इज वॉट per meter Kelvin. It is the very very important. It is the property of material. It is property of material. Okay, चलो. Now thermal conductivity कुछ values देख लेते हैं. So as we know that heat transfer is maximum in solids by conduction. By conduction. तो thermal conductivity solids की सबसे ज्यादा होती है. ओके, तो फॉर एग्जांपल अगर हम मेटल्स की बात करें तो सिल्वर हैज 410. इट हैज द यूनिट्स ऑफ hundreds, 10 to the power 2. Silver, copper is 385, aluminum is 200, pure iron is 80, steel is 15 to 35. Okay, all in the range of hundreds. Okay, now अगर हम नॉन मेटल की बात करें तो उनकी मोस्टली कम होती है मेटल से कंडक्टिविटी. ओके, जैसे कि डायमंड का एक एक्सेप्शन है, वो हम अभी थोड़ी देर में बात करेंगे, लेकिन ग्लास की है 1.2. ग्लास वुल इज वेरी वेरी लो, 0.0038. लिक्विड्स की और कम होती है. लिक्विड्स की होती है 8.21 एंड वाटर होता है 0.6. गैसेस की कंडक्टिविटी इज द लोएस्ट, हाइड्रोजन, हीलियम, एयर. तो क्या मैं ये कंक्लूड कर दूं कि कंडक्टिविटी इन सॉलिड्स, और इंस्टेड लेट्स रिमूव सॉलिड्स, लेट मी राइट मेटल. कंडक्टिविटी ऑफ मेटल is greater than conductivity of non-metal, is greater than conductivity of liquids, is greater than conductivity of gases. बट यहां पे एक एक्सेप्शन है. क्या एक्सेप्शन है? कि भैया डायमंड की थर्मल कंडक्टिविटी किसी भी एक मेटल से कई गुना, ऑलमोस्ट 10 गुना ज्यादा है. यू सी, दिस इज 200, दिस इज 2000, 10 गुना ज्यादा है. तो उसका क्या रीजन है? उसका रीजन क्या है कि डायमंड is a perfectly crystalline crystal. You see, if this is diamond, so the carbon atoms are they are perfectly bonded. They are perfectly bonded, right? Okay, so all the 4 valence electrons are covalently bonded, and there is no free electron. There is no free electron. And therefore because they are perfectly bonded together, जब भी आप इसमें हीट सप्लाई करेंगे तो जो वाइब्रेशन होगा, you see that in solids heat transfer takes place because of molecular lattice vibration energy and free electron transfer, right? अब मैंने कह दिया कोई फ्री इलेक्ट्रॉन तो है ही नहीं, तो ये तो जीरो हो गया. लेकिन जो मॉलिक्यूल्स का अरेंजमेंट है, इट इज सो परफेक्ट कि जैसे ही आप हीट दोगे, ये जो वाइब्रेशन होगा, सो हीट इतनी परफेक्टली डिस्ट्रीब्यूट हो रही है, हीट इज सो परफेक्टली डिस्ट्रीब्यूटेड कि हीट ट्रांसफर हैपन्स मच मोर टाइम्स और मच हायर टाइम देन एनी सॉलिड. That is why its conductivity is very 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 high, because of its perfectly bonded carbon atoms. Okay, so the 4 valence electrons are covalently bonded and no free electrons, and that is the reason. Look, electrical conductivity is because of electron transfer, but there is no electron, there is no free electron here. So diamond has no electrical conductivity but is a perfect thermal conductor. इतना ज्यादा हीट ट्रांसफर ही करता है कि कोई भी नहीं कर सकता. ओके, सो इट इज अ perfect thermal conductor. Diamond is an electrical insulator but brilliant heat conductor, thermal conductor. That is the reason. Okay, instead it is a non metal, but still it conducts heat much faster, much more than any solid. Okay, chalo, let us see this question as well. In descending order of magnitude, in decreasing order, the thermal conductivity I need to find out. I need to arrange them. Pure iron, liquid water, saturated water vapor, pure aluminium. So we already know one thing. What? K in solids is greater than K in liquids and K in gases. Okay, so I know one thing, that I am not sure about pure iron or aluminium, but I am sure about that it will come in the end what? Conductivity of liquid water and conductivity of water vapor. अब पॉइंट आता है आयरन का और एल्यूमिनियम का। तो अभी अभी हमने डिस्कस भी किया और आपको वैसे भी एक आइडिया होना चाहिए कुछ मेटल्स का। ओके, सो इट इज अराउंड 80 watt, K is around 80 watt per meter Kelvin, and this is around 200 watts per meter Kelvin. Okay, so therefore I can say K of aluminium is greater than K of iron, and then this. So this is what? D, A, and then B, C. That is the right answer. So right answer is C, D, A, B, C. C is the right answer. Okay, chalo. Chalo, so I hope that you like the session. If you like the session, let me know. Okay, and we will meet soon. So thank you very much.